This film will show an important test conducted on a small portion of a very large project. It's fundamental for such a large construction project to have the durability to resist extreme loads that the project will be exposed to in one of the harshest climates on Earth. Hebron is a heavy oil field discovered in 1981, located off the east coast of Canada, in Newfoundland and Labrador, Jeanne d'Arc Basin, 350 kilometers southeast of St. John's, the capital. The water depth at Hebron is approximately 92 meters. The field is estimated to contain 400 to 700 million barrels of oil. The Hebron field will be developed using a standalone concrete gravity-based structure, a GBS. The GBS consists of a reinforced concrete structure designed to withstand sea ice, icebergs, meteorological and oceanographic conditions in the North Atlantic at the Hebron offshore project area. The preliminary GBS concept has a single main shaft supporting the top sides and encompassing all production wells. The GBS concept will be further defined during the detailed design stage. One challenge for this project is to achieve maximum durability of the concrete used in the construction. The closely woven reinforcement grids may create problems during casting of the concrete. To demonstrate if such problems do exist, an analogous section of the GBS base slab was recreated as a copy of the real GBS base slab that will be constructed. The test was executed in Stavanger, Norway. Skanska was chosen to carry out the practical aspects of the construction work, including casting and testing, on assignment to Kværner Contractors, KKC.
Vi har funnet et tverrsnitt i plattformen som vil simulere den vanskelighetsgraden vi vil ha når vi skal støype ut.
The following types of concrete were tested. SCC, self-compacting concrete, a relatively new type of concrete mix developed using new types of additives with very low viscosities. SCC concrete can flow and fill the entire casting form without requiring vibration. NC, normal concrete, represents the common and traditional concrete mix, which does require vibration in a normal method using an immersion vibrator. This type of concrete construction is very exacting, with reinforcing steel grids woven into a network of steel bars placed with precision. The methods employed for pouring the concrete and selecting the ingredients for the concrete are crucial to the process. If this work isn't performed in the correct manner, the concrete will not completely surround the reinforcing steel as required, which could result in voids in the concrete that could be porous. That would lead to a weakening of the structure. A concrete flow test was performed on the concrete supply before test placement commenced. This was carried out using a Sula Beton AS, where SCC, self-compacting concrete, was placed into a so-called L-box. This sketch shows how the concrete flows into the bottom of the testing module when a hatch is opened. The camera at the front of the entry shows how the concrete flows through the tightly woven rebar grid. This flow test was performed to learn about the flow properties of SCC. The results from this test show that SCC flows into areas where the openings in the grid are largest, meaning from below and above. The concrete flows at a limited speed between the intermediate layers. The full-scale mock-up test was performed on the 22nd of June 2011. A number of parties were present on the day of the test. The purpose of the test was to determine the best construction method to be employed to provide the desired result for placing concrete in the base slab for the Hebron GBS. The challenge was to determine how to pour slabs that are 2.5 meter and 1.8 meter without the problems that could arise from placing concrete in the form with limited access for vibrators, placing concrete using a filling pipe to avoid segregation, and maintain visual contact with the concrete placing front. Vibrator access was limited due to T-headed bars which were used between the top and bottom layers of reinforcing steel. The bottom layer generally consisted of 6 to 8 layers of 32mm rebar. The top layer consisted of 2 to 4 layers of 32mm rebar. The concrete placement test itself was divided into various experiments, where both SCC and normal concrete were tested. These attempts represent different models of concrete placement methods directed at the reinforcement placement and casting heights.
Og det dette testen vil vise, det hva som mulig, hvilken metode, type betong som vi må bruke for oss å få dette til.
The mock-up test itself commenced with SCC being cast in areas 2 and 3 on the mock-up.
Så det vi gjør akkurat nå, det er å støpe ut med SKB-betong, selvkomprimerende betong. Det er totalt 42 kubikk. Etter hvert så vil vi fortsette med vanlig betong, og så vil vi avslutte med normal betong som lag nummer 2 på toppen av SKB.
SCC flowed well, but it showed clear signs of segregation when it flowed over a long distance. To counteract this condition, it's important to use the concrete placing boom in a 2 by 2 meter checkerboard pattern. The concrete should not be vibrated right after placing the concrete. Vibrating the concrete is only possible after the concrete has been placed about 1 hour. It was observed that the reinforcement at the bottom acted at times as a barrier against the concrete, and the concrete flowed over the top rather than between the reinforcement layers. Corridors were maintained in the rebar grid to allow access for inspection and follow-up of the concrete work where deemed unnecessary. The T-headed bars had to be installed after placement of the concrete over the bottom layers of reinforcing steel, which proved to be quite difficult. As the test progressed, it was determined that it was not necessary to use filling pipes if the pump truck concrete placing boom contained a hose of reduced diameter. The lower part of the boom hose was sunk directly into the concrete to avoid concrete drop. Normal concrete was poured in a similar method by distributing, using a concrete placing boom and filling pipe through the top reinforcement in an approximately 2 by 2 meter checkerboard pattern. The concrete was first poured into Area 1, where there were few challenges regarding the concrete flow or vibrator access. Corridors had been left out of the T-headed bars for the purpose of access for inspection, but this proved unnecessary. All work required to pour the bottom layer could be accomplished from a position above the upper rebar layers. Area 4 presented one challenge, where there was reduced opportunity to vibrate the concrete in every second checkerboard zone from the top layer and penetrate through to the bottom layer. Vibrator access was limited because of the closely woven reinforcing steel grid in the areas of the top layers of reinforcing steel. The T-headed bars had been installed in each grid system, except for the corridors created by leaving out T-headed bars for access. This led to difficulties when vibrating from the top layers and into the bottom layer. However, it was possible to vibrate through the top layer and into the bottom layer, because the position of the T-headed bars to a certain degree were flexible in the bottom grid, and the vibrator could move the T-headed bars a little to the side to reach the bottom mesh. One conclusion arrived at, following the test, was that the corridors of missing T-headed bars were not necessary at either 1.8 metre or 2.5 metre slab thicknesses, to the extent that these bars were left out in this test. It was difficult to install the T-headed bars after the bottom layer of concrete had been poured. It was not necessary to do any follow-up during pouring, as was planned. It was concluded that there was sufficient visibility and it was possible to observe the concrete from the top of the reinforcing steel layer where that the layers were aligned vertically. The second layer of normal concrete, NC, was poured in a normal process both onto the self-compacting concrete, SCC, and on top of the first level of normal concrete. No problems were encountered in these operations.
Vi føler jo vi har bevist, eller vi har fått vist dem hva som mulig å gjøre. Så det er vi litt fornøyd med.
Jeg tror mange som har sett noe helt nytt. Dette med SKB er ikke, som sagt, helt vanlig i vår bransje, så mange har lært hva egentlig SKB er og hva det innebærer.
Cores were bored after suitable setting time to show that the pouring technique was effective and to demonstrate that the concrete did surround the reinforcement grids in areas where NC was used. In SCC section, in some areas, porous concrete was observed around the rebar, which might have an influence on the properties and relationship between the concrete and the rebar. The test showed that NC is preferable for casting the bottom slab, because SCC is not quite as robust as NC. The following conclusions can be drawn after our experience from this test. When using SCC, minor variations in moisture content when weighing the materials could create major variations in the properties of the fresh concrete beyond what may be considered normal for NC. During the pouring sequence, SCC proved more sensitive to segregation than NC. Heavy rain would be more detrimental for SCC than for NC. The small concrete barrier walls used in the mock-up would be required if SCC is used. When using NC, normal concrete with high workability will eliminate most of the disadvantages of using SCC. NC is robust, and variations in moisture when weighing materials would have a less significant influence on the properties of the fresh concrete. NC is easy to pour and vibrate. Concrete barriers are not required for NC.
Men det vi har vist er at det går veldig fint med å bruke normalbetong allerede i første lag, og fortsette med normalbetong i andre lag, også de påfølgende lag over.
Construction of the GBS is expected to begin in 2012, and it's expected to generate over 4 million man-hours of construction employment. The test conducted in Stavanger, Norway, was successful because answers were found to help decide the concrete and pouring technique. Experience from the test can now be used as a basis for constructing Hebron GBS in Newfoundland and Labrador, Canada.